Hello, everyone. My name is Mario Garcia. I'm so happy to be here sharing with the community. My talk will be about vector databases on AWS. You can contact me through my email. You can also check some of my blog posts on my dev account. And this is the agenda that we will follow. We will talk about what is a vector database, about embedding models, how do we prepare the data, and finally, how do we deploy the infrastructure. And I will show you a rack system demo that I prepared for this presentation. So imagine that we have a text that the one you see in the slide. Artificial intelligence is transforming the way we process data in Postgres. The idea with vector databases and the main concept behind this technology that is embedding is that we convert this text to something that LLMs can understand, and is a way that we can teach these AI applications to learn about topics that they don't have enough information, or they have wrong information. So that is an embedding. So we convert this text to a vector that contains numerical values, and these values represent the meaning of the data. So the way that we store, index, and query the vectors is what we call a vector database. Well, before talking about embedding models, we can use Postgres, and we will focus on Postgres for deploying a vector database, but there are other technologies that we can use for this purpose. So when we talk about embeddings and the way that we can convert not only text, we will focus on text, but we can use OpenAI, Google, and applications like Olama or sentence transformers. The difference is that for the first two and the models they provide, we must create an API key to access the models and use the SDK, the official SDK that they provide, for example, for Python. But every time we try to convert any data to an embedding using these models, we need to connect to this model using the API key. So the difference with Olama and sentence transformers is that we don't need to establish a connection. We can download the models and have them locally. So we can use also these applications for that. The difference between these models is the dimensionality. I mean, when we convert any data to an embedding using these models, this will have a specific size. And for example, these are some of the most used models. The first two are the ones that OpenAI provide. And these are the dimensionality that these models have. We can use the one that provide Google, but for this, for the demo that I prepared, we would use Titan, that is one of the models that Amazon provides through Amazon Bedrock. We can use text, images, audio, and a combination of text and images as data sources, but we will focus on text. We can use data sets, we can query the information from any database, or we can create a script for randomly generate the data and convert that data into an embedding and then insert that data into Postgres, for example. We will use a movies data set provided by Learn Data Science, and the model, and we will use one of the models provided by Amazon Bedrock. Amazon Bedrock is a managed service that we can use for accessing models from different providers, including Anthropic, Meta, Mistral, and Amazon. We will focus on Amazon Titan. We will use one of the models that Amazon provides. And for this data set, after analyzing the content, these are the columns that this data set has. We won't use all the columns. We will insert only part of the data, but we, when converting to an embedding, we will use most of the columns in the dataset. I prepare the embedding or the vector database locally. So I create a database named movies, then change to this database, and we have to enable the extension. So we run this query for enabling the vector extension, and then we create a table inside this database. So we will have an ID, we will have the title, and some of the other columns available in the dataset. And we will convert part of this data into an embedding and insert that data in a column inside this table. So the data type that we will use is vector, but we also have to specify the dimensionality of the vectors that we will store in this database. And in this case, as we are using this model provided by Amazon, the dimensionality of this model is this one. So this is the size of the vectors that we will store in that table. Well, we need to configure the CLI. We will use it only for creating the embeddings, as we need to access Amazon Bedrock. So we will only do this for this part of the process. So we need to go to the AWS console and then there create a user. So we need to create a user and attach some policies so we have the permissions to access Amazon Bedrock. So after creating the user, we go to user details, then go to security credentials, and then we need to create an access key, and we go back to our terminal and run AWS configure, and it will ask for the access key, that information about the access key that we created before. Then we convert the content of the dataset that we downloaded previously, the one that that we have here. It only has about 1,000 records, so it will take about 30 to 40 minutes to finish the creation of the embeddings. Well, it takes that amount of time because it has to connect to AWS and use the models provided by Amazon through Amazon Bedrock. So that is why it is taking so much time for only 1,000 records. And the script for that, you can check the script in this snippet I created, but we could also see it here. So we have here some snippets, and this is the one for that contains the script for generating the embeddings. So it basically will connect to the, well, it will read the data set, then connect to Amazon Bedrock and use the model that we showed previously and start creating the embedding. We only have here these columns: title, genre, description, director, and actors. We will use that as metadata, and we're going to show that information once we create the app for semantic search. And these are the columns that we will concatenate for creating the embeddings. So there's, after creating the embedding, we insert that data into a PostgreSQL database. And then we need to back up that database. Well, I upload the SQL file to the GitLab repository. So GitLab CI will read this file, and once we deploy the database to AWS, we import that data into the database created. So after creating the embeddings, how do we deploy the infrastructure? We need to create an identity provider. We will use GitLab as our identity provider, as we don't have to create a user and set the variables in the CI/CD configuration of a repository, but we can use GitLab CI directly to generate the necessary tokens for establish the connection to AWS, and through some policies that we will create later, we provide the necessary permissions for GitLab CI to create all the components of the infrastructure. So we create an identity provider. We go to this section in the AWS console. We follow the steps described here. We click on Add Provider, select OpenID Connect, and then set the provider URL to gitlab.com as well as the audience. Then we need to create a policy, and this policy will have these permissions. We can check this file later, but these are all the permissions required for GitLab CI to deploy the whole infrastructure. And well, we create the policy, we changed the editor to JSON, and we copy the snippet that I showed you before. Replacing the account ID on line 52, that is important because this is your account ID, and we name the policy as GitLab deploy policy or the name that you want to use. Um, then we need to create a role. Also, we have a snippet here that contains all the, um, well, we set the trust policy using the snippet that we have here. And this one, well, we need to specify what is the provider that we're using for deploying the whole infrastructure, but we also need to tell AWS what is the repository that contains the configuration file for the deployment, but also the Lambda function. We will later see that, and all the necessary files for deploying the infrastructure. And to this row, we attach the policy that we previously created. And then we need to create the Terraform configuration file. We are using Terraform. Um, Terraform we will use the default VPC, but also we'll create a security group for the port that Postgres will use. We need to create a Postgres instance. We're using the 17 version, and we need to deploy the Lambda function that contains the, well, where we configure the semantic search. We will later see the demo working using this function. And another role that it requires, as well as creating the CloudWatch logs and exposing the endpoint for the connection to the database. And we can check the file directly in the repository. We create a Lambda function. Well, what the Lambda function will do is that we will have an app that will do a semantic search, and the function will receive the request by the user, then connect to Amazon Bedrock, convert that text into an embedding, then query the database, and we'll search for similar vectors. So we will have the results, we will obtain the results based on that. Before deploying the infrastructure, we need to configure the CI/CD variables. We need to create 3 variables, one for the account ID. We need to obtain this data from our AWS account. We need to set also the default region. I'm using US East 1, but you can change that based on the configuration of your project. And we need to create a password for the database. Now we have all the necessary files for deploying the infrastructure. It will create the database in AWS, but we need to configure GitLab CI to deploy the infrastructure, but also load the data into the database, deploying also the Lambda function, and we will add another job for cleaning the infrastructure after after deploying the infrastructure. If we don't need the database anymore, we can run this job manually for deleting all the components that GitLab CI created through Terraform. And the connection to AWS will be through the identity provider that we created at the beginning. And we will have these 3 jobs configured in the GitLab CI configuration file. You can check the configuration file directly in the repository. And when we deploy the Lambda function, we also need to include the library for establishing the connection to the Postgres database. We're using this library for that, but as we cannot use any public layer that already contains the runtime, and where we can also install the libraries that the project require. Well, this happened because as we are using GitLab as an identity provider, it doesn't have access to these public layers, so we can use those Python runtimes. We can make any changes to those layers, and we can when we deploy the Lambda function, we won't have the binary of this library available. So that's why we're adding this binary to the zip file that contains the Lambda function. And we have that file here that all the jobs that I explained before are the ones that are in the configuration file. And the last one is for deleting the whole infrastructure. And this is a job that we need to start manually. So, okay. And well, I was talking about rack systems before, but what is a rack system? Imagine that when you use an AI application, we request information about a specific topic. It can happen that the answer that give you contains wrong information, or the information is not updated, or it doesn't have enough data about a specific topic. So how do we, for example, make that OpenAI or Gemini or any other AI application to learn about topics that they don't have information about. Well, that's where we can use a rack system. The idea is that with any data source, this LLM can use that data for learning about another topic, a topic that doesn't have information or knowledge about, and we can get better responses when we ask for information about, for example, um, movies, and we will see some examples about that. And what we're creating for the demo is actually a small application that uses the vector database for learning about topics and give better responses when we ask for information about movies or any other data that the data set that we are using have about this topic. And we have two files. We have the Python app, and this will send request to the Lambda function. The Lambda function, as I explained before, it will convert that text into an embedding, and then will query the the vectors that are similar, and that is the response that we will receive. So the calls to the Lambda function will be done through the Python app, and we will show the responses in the browser using this template. It will have it will have the it will show the information that we ask about. So you can also check the code for these two files in the repository. But now let's see how the application works. So we have here the app, and we can ask for movies, request information about movies, for example, related to time travel. We will call the Lambda function. The Lambda function will get the similar vectors from the database, and this is the response that we get from the Lambda function. For example, we can try with movies directed by Guillermo del Toro. And this is the list of movies that are the most similar to what we're asking to the AI that we're using. So if we are not getting enough information about a certain topic, this is how we can do an LLM to learn about other topics that doesn't have information about. And we deploy the whole infrastructure to AWS using Terraform, but we can also deploy to other platforms. But considering the technologies that we're using for building our application, we're using a Postgres database. We're creating a function that will receive the request and convert the text into an embedding, then query the database. And we have an application that if we as users need to get that information, we can use that app to ask for information about movies. So this is as well, the data set that I chose was a small one because, as I told you before, it takes so much time for converting into and embedding the data or the information that we have in the data set, because it has to establish the connection to Amazon Bedrock to have access for the models that we are using. But if we decided to use Olama or sentence transformers, for example, we need to, when we deploy the Lambda function, to also add those models. So the Lambda function would also have access to those models, as when we create embeddings, we use the same model for converting the data into an embedding, and to also query that data from the database that we choose for our project. So if we're going to use any model provided through Olama, we need to also use Olama and include the models we're using when we deploy the Lambda function. We don't do that for this example because we're using Amazon Bedrock for converting the data set into embeddings, and we're also using Amazon Bedrock for query the data from the database through the application that we created before. I don't deploy the application to AWS. I'm using the application locally, but you can also add that configuration to your Terraform configuration file and run the application directly from AWS, for example. So this is what I prepared for this presentation, and I hope it will be helpful for your projects. You have all the configuration files in the repository, and you can adapt those files to your project. Don't forget to modify the information in the variables, replace the account ID and the other information or credentials that GitLab CI require for running all the jobs in the CI/CD pipeline. So I've been writing about vector databases and also RAG systems. You can check that on my dev account, and I'm preparing more articles on that topic. So you can check later more detailed instructions on how do we prepare the infrastructure for our projects. And if you have any questions, you can contact me through my email or to any of my social media accounts. So if any questions, I will be available through my email. You can contact me whenever you have any questions on this topic. And just want to say thank you for attending my talk, and really hope that it will be helpful for your project. Thank you.